we explain how to use Unity to build a training environment for PPO training to train this agent to learn how to reach the goal while avoid hitting this obstacle over this wall. Okay, previously we have been using DQN to train this agent. Now we move to PPO. DQN is based on value optimization, whereas PPO is based on policy optimization. The difference between value optimization, policy optimization, and imitation learning, I will explain the details in class. So here I just simply skip. Okay, this demo is created using Unity 20.0 and ML Agent 0.14.1. If you use other version of ML Agent, be sure to notice the difference. Okay, you might modify a little bit. So here's the scene. It's similar to previous one. Okay, this is plane. This is agent. This time I add 9 sensors to this agent. Okay, here you can see the first one rotate minus 85, the next one minus 65 by 20 degrees, minus 45 and minus 25, 0, 25, 45, and 65, 85. And this is goal, and this is obstacle, and then I have 4 walls because I need to detect the distance. Okay, that's the scene design. It's similar to our previous one. Now the agent, we need to add a rigid body component because in the script, in the agent script, we need to detect collision detection. So when the game object is at a script in which we need to do collision detection, we need to add a rigid body to this game object. We only need to add rigid body to the game object that has script. Others, for example, Go actually I add one, but actually I don't need. Other objects I don't need to add rigid body. Okay. And then the behavior parameters. This time the space size is to 21. It's because the state delta x, delta z, and theta is similar. And then I have 9 sensors. For each sensor, I record 2 values. The first value is 0 over 1. If it's 0, means this sensor does not hit anything. If it's 1, means this sensor hit something. If the status is 1, then I record the distance from the sensor to the object. If it's 0, then I just simply record 0. Since I have 9 sensors, for each sensor I record 2 values. So in total, I have 18, 20, 21, 19, 20, 21. So the space size is 21. And then the action type here, the action is continuous. Okay, it's not like DQ1 this time is continuous. And the space size is 2 because we only need a vector. The first one record the speed and the second one record the angle. And both values are normalized to -1 to +1. Okay. And then the second script is the agent script. The agent script. Okay. We have 9 public variables to store these 9 sensors transforms. So remember, okay, you have to drag this sensor, okay, to 1 to 1, for example, 3 to 3, okay, blah, 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 okay? And similarly, you have to assign goal and obstacle, okay? And then the details of this, okay, first this script, let me open this script. Okay, so the overall structure of this script, okay, is like this. Okay, and the first one, initialize agent, we do not implement anything. The second one, collect observations. We simply collect the 21 values for the state. The first three, delta x, delta y, z, and theta, we already discussed it. And then for the 9 sensors, if the sensor collide with something, then the status is equal to 1, and the distance, we record the distance. If the sensor does not hit anything, then the status is 0, and the distance, we let it become 0. And then the agent action here, because it's continuous, so we take the first value of this agent vector, of this action vector is the speed, and times a factor, because its value is normalized to -1 to 1. So you multiply a scaling factor according to the speed you want. Similarly, you multiply angle factors. Here I already changed it to +5. Okay, well, it actually won't matter because the value is -1 to 1. So if you want to rotate right, then you times plus. Okay, so either way it will work. And if the distance is less than a threshold, I add a positive reward to say, okay, otherwise I add a minus punishment based on the distance to go. You might refer to Carl's reward design, which I already put in Portal for the homework 4. Okay, he used Manhattan distance rather than Euclidean the distance. Okay, this is action, and then agent reset is the same. Okay, just define it as 0. Then this on collision enter, just detect whether my agent collide with. So here in the PPT is wrong. Okay, I just want to detect whether my agent collide with something. Its tag is block. So in the scene, okay, I assign the block is tag block, and also this wall is tag is block. Okay, so I simply detect if the agent collide with something the tag is block, then I just add a reward. Okay, and then finally the update. Okay, so this is the agent script. Okay, let's run it to see. Okay, here's the PPO. I will explain the details of PPO in class, so I just simply skip. So now I just connect to the Unity. Go to Unity, hit play. Okay, and reset. Okay, if you want to run step by step and print out the intermediate result to understand the PPO code, you might go to the appendix and run it. That's how I learned the PPO. Okay, here I just simply demo. Okay. So now I train this agent using PPO rather than DQN. Okay, because I just simply demo, so I quickly stop it. And here we just run. This code is used to collect a set of transactions for imitation learning scale. Okay, so we will discuss it in class. Okay, here simply just run to collect. Okay, now I close the environment. Okay, with this we finish explaining how to use Unity to design a training environment for PPO.